Solving rational and radical equations. We're going to start by looking at solving rational equations. Here are the 4 steps that we need to note. Step 1, create common denominators. Rational equations are just equations that have fractions with x in the denominator. So we're going to make common denominators so that we can combine these fractions. Once we have common denominators, step 2 is going to be to set your numerators equal. So once all the denominators are the same, we can just set our numerators equal. Step 3, we're going to solve that resulting equation. This could be linear or quadratic. If it's quadratic, make sure you're factoring. Step 4, check to see if your solution is excluded from the domain, which we will talk more about in a minute. In order to solve rational equations, we need to start by finding a least common denominator. So we're going to practice that here. I'm not going to go through and solve each of these. We're just going to find common denominators for each. This first one, my denominators are 3, 4, and 2. So I want to find a number that 3, 4, and 2 all divide into evenly. So first of all, I would start with your biggest number, 4. 3 doesn't divide into 4, so that's not going to be my common denominator. And then multiples of 4. 8 is next. 3 doesn't divide into 8. Next would be 12. 3, 4, and 2 all divide into 12, so that's going to be my least common denominator. You can denote least common denominator by LCD. The next problem has a denominator of x minus 1 and x and 1. Make sure that if there's a term without a denominator written, that you write it over 1. So now I'm looking at all the different things I have. Think of 1 as a free space. I'm not going to include that in my least common denominator. So I just need to have an x and an x minus 1, a factor of each of those, in my least common denominator. So my least common denominator is x times x minus 1. In the next problem, I have an x plus 6 in one of my denominators, an x minus 2, and then I have a quadratic that I can go ahead and factor. 6 and negative 2 add up to 4, and they multiply to negative 12. So now we can see that that denominator actually has a factor of x plus 6 in it and an x minus 2. So my least common denominator is going to be x plus 6 and x minus 2. The next problem has an x minus 2 in one of the denominators, an x plus 2 in the other denominator, and then x squared minus 4 is a difference of squares. So I can factor that by square rooting x squared and square rooting 4. So I get x plus 2 and x minus 2. So this problem will have a least common denominator of x plus 2, x minus 2. And the last problem, we have an x squared minus 9x in the denominator, so we're going to start by factoring it. Just pulling out a greatest common factor of x. And we technically have 5 over 1. So looking through my denominators, I have an x and an x minus 9 in the denominators. So that's going to be my least common denominator. After we solve the equation, we need to see if the solution is excluded from the domain or not. Let's practice finding what values of x cannot be the solution. So once we solve these rational equations, we're going to have x equals a number, or maybe x equals 2 numbers. Now, the reason that a solution may be excluded from the domain is if it makes a denominator equal to 0. So with our first problem, our denominators here are x minus 1 and x. So we need to stop and think about what makes each of those 0. The value that would make this 0, the number that if we plug in for x here that would make this 0 would be 1. And if we plugged in 0 for x here, then the denominator would also be 0. So for this first one, x cannot equal 1 or 0. For the next one, we need to start by factoring x squared plus 4x minus 12. We can't tell what's excluded until everything's factored. So again, I'm looking to see what would make this 0. Well, that would be if x was negative 6. And what would make this 0? That would be if x was 2. And same and same, we just have repeats. So the two numbers that x cannot equal for that problem would be -6 and 2. For my next problem, again I need to factor the x squared minus 4. And then I'm looking to see what makes each of these 0. Well, that would be just 2 or -2. So x cannot equal 2 or -2. And for the last one, again, we have to start by factoring. And then we're looking at what makes each of these 0. So what makes that 0? What makes that 0? What makes that 0? Well, if x were equal to 0 or 9, those would be excluded. In our first example here, we need to first of all put x over 1 so that we have all of our denominators written. So we've got 2, x minus 3, and 1. Again, 1 is a free space. Don't worry about it. So my least common denominator here needs to have 2 and x minus 3 in it. So that's what it will be. My least common denominator is 2 times x minus 3. Now, in order to get each of these fractions, I have 3 fractions going on. In order to get each of them over 2x minus 3, I'm going to multiply the top and the bottom of each fraction by whatever isn't in the denominator. So this first fraction here, 2x plus 1 over 2, it has a 2 in the denominator. So I'm just going to multiply the top and bottom of this fraction by x minus 3. So now you'll notice in the denominator I have a 2 and an x minus 3 in this fraction, which is my least common denominator. Okay, for my next fraction, I have a 5x over x minus 3. I already have the x minus 3 part, so I'm just going to multiply the top and the bottom by 2. And my last fraction, I have a 1 in the bottom, so technically I don't really have much. So I need a 2 and the x minus 3. So we're going to multiply it by 2 times x minus 3 on both the top and the bottom. Okay, so for my first fraction, I'm going to have to do FOIL or box method with the numerator because I have x minus 3 times 2x plus 1. So if I FOIL that out, here's what we get. And just leave the denominator like it is. No need to distribute the 2 in. Okay, for my second fraction, I'm multiplying the top and bottom by 2. And then the third fraction, we're going to need to be careful here. We're distributing both a 2 and an x. So maybe we should distribute the 2 first. You get 2x minus 6. And then distribute the x. Or you could just distribute 2x all at once, which is what I did. So 2x times x and 2x times -3. Now as we look across the equation, we have common denominators. And we can just set the numerators equal. I like to circle that. So I'm circling all of my numerators and that plus sign and the equal sign. I'm going to combine some like terms here on the first fraction, and this is the equation that we end up with. Now notice I have a 2x squared on both sides. So if I subtract 2x squared over, those are just going to cancel out, and I'm going to be left with a linear equation. Pause your video now and solve this equation to see what our solution is. Okay, now we need to check to see if our solution is excluded from the domain or not. So looking back to my original problem, whenever I look at the denominator, the only place that I have an x is for x minus 3. So my restricted value, or the number that x can't be, would be 3. And that's not what I have here, so this is my answer. Example 2. The first thing I need to do on example 2 is factor the first denominator. Anytime there's something that you can factor, you need to do that before you find your least common denominator. So this is just a binomial. I can pull out a greatest common factor of x, and that's my new denominator there. So looking through here, I have an x and an x minus 9 in each of my denominators. So that's going to be my least common denominator. The first fraction is already over x times x minus 9, so I don't need to do anything to it. The second fraction, though, only has the x minus 9 part, so I'm going to multiply the top and the bottom of it by x. And my third fraction, 3 over x, needs the x minus 9 part of the least common denominator. So I'm going to multiply that on the top and the bottom of this last fraction. So I'm just going to rewrite the first fraction. The second fraction, I'm going to multiply the top and the bottom by x. And the third one, multiplying the top and the bottom by x minus 9. Now that my denominators are all the same, I can just set the numerators equal. We get a linear equation because there's no squareds, so go ahead and pause your video and solve this equation on your own. We get x equals negative 14. Again, if we go up and we check our restricted values, so what x can't be, would just be 0 and 9. So x equals negative 14 is an acceptable answer.